Hi everyone, myself Dr. P. Kanagraj, Associate Professor, Department of Computer Science and Engineering, Sri Sanhua College of Engineering and Technology. Now we are going to discuss a concept called tokenization in large language model. So we will start with the introduction of large language model. So an LLM is a deep learning model trained on a huge amount of text data. The main goal of LLM is to understand and produce language similar to how humans are doing. So LLM are used for various tasks. Some of the tasks are translation, summarization and answering questions, etc. The next, some of the basic things about AI, ML, DL, LLM. So machines doing intelligence tasks like humans. So that will be created with the help of AI. Next, machine learning, AI that learns pattern from data and improves with experience. Next, deep learning, in that ML using many layer neural networks to learn complex patterns. Next, large language model, in that deep models specialized in understanding and generating languages like human. Next, architecture of large language model. So for this LLM, we are giving some text which will process and produce the output based on the given input. So in between, what other things are happening in LLM? So first, input text, the text sequence you give to the model. The next process is going to be tokenization. So what is tokenization? Text input is split into smaller units called tokens. So then next, so which is passed on to things, word embedding, positional encoding. What is word embedding? Tokens are mapped to dense vectors representing their meanings. The next, positional encoding, so it is add, so order of token, so within the splitted tokens. For the tokens, it will provide the order of arrangements with help of positional encoding. So after these process, it is given to the transformer block. So what transformer block will do? This is the core of computational unit in most large language models. So it contains a stackable model that processes entire sequence of text in parallel. It reads words at a time, transforms, analyze and all tokens simultaneously. The transformers analyze all tokens simultaneously. Each block includes three main components. Transformer block includes three main components. So one is attention mechanism, next one is feed-forward neural networks, and next one is normalization layers. What is attention mechanism? It captures contractual relationship between tokens. So feed forward neural network, it interprets the results. So this feed forward neural network having multiple levels. So with the help of that, so the model is going to be trained. The next, normalization layers, so which will help us to training stability. So more to give more training to produce good result. So it's the purpose of normalization layers. Next, output text. So after stacking multiple transformer blocks, the final vectors are decoded back into tokens, so and then text. Next, we are going to see a little bit about tokenization. So large language model having two important things, tokenization and transformation. So here tokenization we are going to discuss now here, a little bit detail. LLM tokenization is the process of turning raw text into numeric tokens that a LLM can understand and process. So what are the steps have happened within tokenization process? Step 1 is user types a message. So for example, hello world, how are you doing today? So the given text is splitted into tokens. How the splitting is going to happen? For the different algorithms are used. So most commonly used algorithm is byte pair encoding. So this algorithm used for splitting the given text into tokens. The next, for each converted token or each created token, there's an unique ID is going to be assigned. That is tokens converted to numeric IDs. So for each token, again it is converted into numeric IDs. So that numeric ID is given to the transformer block, and then transformer block process whatever they are giving, process, then finally it will produce the output. So this is the main things. So given text is split into tokens. For each token is converted into numeric IDs, unique numeric IDs. So just whatever we discussed the same thing. Start with raw text, take an input string. Step 2, split into tokens. So for that splitting purpose, we are using different algorithms. So one is word or white space tokenizer, which is split based on space or punctuation. Second group is subword tokenizers. Subword tokenizers having different algorithms, byte pair encoding, BBE, word fees, sentence fees. So these are the subword tokenizer algorithm. So which is not based on, which is the given input string is not divided or splitted on space. So which is based on pairing concept. So this subword tokenizer technique start from characters and repeatedly merge common character pattern from large and meaningful subwords. Next, map tokens to IDs. So each token string has unique integer ID in that model. The next, add special tokens. At the end of each token, special markers are inserted so the model understand boundaries of roles. So next, finally convert IDs to embedding. Each token ID is mapped to a high dimensional vector in an embedding matrix. Positional encoding are added so that model knows the order of tokens. Finally, the sequence goes into the transformer block for processing. So after the first is text is given as input, which is splitted into tokens. For each token there is an ID is going to be assigned, then which is passed to the embedding positional encoding. So after that, which is given to the transformer block for further processing. This is a small Python program. So just this will convert given, this string is given, the string is converted into tokens. So for this we are using JATGTP2 tokenizer model. So already the tokens are defined, so that from that we are going to split and assign IDs. So this is the input text. We are trying to pass it to the tokenize method, which will split the string into multiple tokens. The next, that is printed. Those subwords are printed. The tokens generally called as subwords, which are printed in the output. The next, for each subword, there is an ID is going to be assigned unique ID. So that is we can done with the help of convert underscore tokens underscore to underscore IDs. So for this we are passing the token which we have identified. Then this will produce assigned unique value. Just this program for the given word which will provide tokens and this corresponding unique ID. So why tokenization is required? Neural networks works with numbers. So tokenization convert text into integer IDs that can be embedded into vectors and fed into the model. So neural network work on numbers. So LLM having stackable models based on neural networks. So if you are giving input for this LLM model transformer block in the form of integer, it is easy for that model to perform the operation. The model then learns patterns over token sequence rather than over raw characters or string. It's a simple example. Assume there's a word banana. How it is going to be split? So this for the split we are going to use byte pair encoding BBE, byte pair encoding algorithm. With the help of that we can split. For example, start with banana. So initially, non-repeating characters. Which are the characters are not repeating? There are two files are normally creating. One is merge file, another one is vocabulary file. So within vocabulary file, we are going to add vocabularies. So from this vocabulary file only, the ID is going to be assigned. So which are the unique characters here? So there are three unique characters. So one is B, so another one is A, another one is N. So there are three unique characters initially which are stored in the file. Some numbers are assigned. For example, 11. This one is 12. So N some value 13. Next, we find the pair. We need to find the pair. So for that, letters are separately we are writing. The next, we try to tag pair by pair. So in a sequential manner, BA one pair, next AN another pair, next NA another pair, next again AN another pair, finally NA another pair. Here, so we have to find repetition of pairs. BA not repeating, only once occurred, but AN two times occurring, AN two times, NA two times. So the first we have to merge highest pair characters. So here there are two things occur. We can do one by one. First we are taking AN. First we are going to take AN. Anyone we can take. First we are going to take AN. So AN are going to be merged. This is a merge table. Whichever characters we are merging, whichever character group we are merging, that is we are putting in merge table. So after merging we are getting a new token AN. So already three tokens BAN created. Now a new token AN is added in the vocabulary file. This BB algorithm going to work with two files. One is merge table, another one is merge table file, another one is vocabulary file. Whichever characters merging, so that information are given. So the merged character we are putting in vocabulary file. With further we are going to give unique ID. So after this, first we are going to merge AN. So wherever AN occurs, this one AN is occurred. Further we are getting merged. Another one is second AN, that is also merged. After merging we are getting B, AN, ANA. Now again the process is going to repeat like this. We are going to repeat. Find the pair PAN one pair. So PAN, next ANAN, next ANA. There are three pairs are created. We are finding the pair counts. All the three having occurred individually. So if it is all are equal, we can choose anyone. For example, we are choosing AN. So these two are going to be merged next. Next pair is going to be, there are two AN. Two times we are putting a merge operation, that's why two times we are putting AN. Here AN. So the AN is going to be merged. So this is small a. AN is going to be added in the vocabulary file. So after this, what we are going to get, AN is going to be added, B, AN. Now three groups. Now next, these are going to be paired, B, AN, next AN. So each one is occurred only once. So anyone we can choose for merging. For example, this one I am taking for merging purpose. B, AN is going to be merged. What we are getting? So B, AN, which is also added in the vocabulary table as well as merge table. After this, we are having B, AN, A. So there is only one thing, so one pair. So this is going to be merged. So this is a merging thing. We are getting banana. Yes, that's it. So no pair is more possible. We can stop the process. So these are the tokens. These are the tokens. These are the merge content. So two things. So first we have to train tokenizer. First we have to train tokenizer. This is a technique used for train tokenizer. Second thing, so token conversion. For that also the same thing. We have to split and check whether splitted token is present in vocabulary table. If it is available, so which will take that ID and assign for that token. If it is not there, which may take nearby word. So thank you for watching.